class. In today's lesson, we're going to be going over solving quadratic equations using the quadratic formula. The learning intention is to know what the quadratic formula is and when to apply it, to be able to use the quadratic formula to solve a quadratic equation, to know what the discriminant means and what it can be used for, and to be able to use the discriminant to determine the number of solutions for a quadratic equation. At this stage, all of you guys should be able to find out the x-intercepts for our quadratic equation by using some of the methods that we've explored so far. So for instance, we've looked at using square roots to solve for x. We've also looked at the product sum method and using the null factor law to solve for x. And just recently, I've also shown you how to complete the square to solve for the x-intercepts. But as you probably are aware, this method over here is quite time consuming and is quite difficult as well. So I'm going to show you another method, and I think you will find by the end of today's lesson that this method over here is a lot more efficient compared to completing the square. And it's probably the second fastest method of finding out what the x-intercepts is. So I want to show you how to do this right now. So what is the quadratic formula? Well, it's a technique for us to find out the x-intercepts when the equation is represented in the standard form. So what I mean by that is when it's in this particular form over here. And it's also tell us the number of solutions, meaning the number of x-intercepts as well. So what does the formula look like? This over here is what the quadratic formula looks like, and what the letters B, A, and C, what they represent are just the numbers that's found in the quadratic equation when expressed in the standard form. Now, what I do want to do is I want to redirect your attention to this symbol over here. Can you guys notice that there's a plus and takeaway sign? And because there's a plus takeaway sign over here, you can kind of like rewrite this in a different way. So instead of writing our quadratic formula like this, which is how students often get confused, I'm going to write my equations like this instead, and it has the exact same meaning. So in this case over here, there is a positive version because this over here is positive, and there's also a negative version as well. Now you might be thinking, why are there two different versions? Okay, and pretty much the answer to that is because for a parabola, the maximum number of x-intercepts is going to be 2. So that's the reason why we need to have two formulas to take into consideration of the fact that you might have two x-intercepts as shown down below over here. Now, what makes this method over here like God tier? What makes it so good? Well, the reason why it's so good, as I said, it can solve any quadratic equation. For the product sum method, remember that you might encounter some examples where you might not be able to factorize it. So in this case over here, if you can't factorize it, use the quadratic formula instead, and this will give you the answer quite quickly. But also it is a lot more efficient because all you're technically doing is just inserting numbers into the formula, simplifying it, and finding out what that actually equates to. Okay, so let's go through some examples so you can see what I mean by this. So in our first example over here, you got 2x squared plus 2x minus 12 is equal to 0. All you're doing is stating the values of A, B, C, plug it into the formula, and you get the answer. So in this case over here, you should agree that these are the values of A, B, and C. Now remember that this is how the textbook and most internet sites write the formula, because as I said, most students often get confused about this and get this wrong. What I'll do is I'm going to write the positive version as well as the negative version. Okay, students often forget the negative version, so that's the reason why I write it as two separate working outs over here. And as you can see over here, all the numbers should technically be identical, but the only difference is these two signs that I've indicated here. So let's now just simplify this. So if I simplified and multiplied it, this is what my new working out steps will be. So let's now add the numbers inside this third. So therefore that gives you 100. Notice over here, that's a nice answer. So square root of 100 is going to give you 10. And therefore simplify, these are going to be your values of your x-intercepts. So it's going to be positive 2 as well as negative 3. And as you can see over here, that's kind of easy, but it's just that we've got very big numbers to deal with, okay? But you will have a calculator to do, so it's pretty easy actually. Let's look at another example. So find out the values of A, B, C, and once we've done that, we'll put it into the formula. Remember, you put it into the positive version as well as the negative version as well. So if you do that, then this is what your working out should look like. And in this case over here, you just go 25 minus 12. Now, in this example, if you notice that you're not going to get a perfect square, so 25 minus 12 is going to give you 13. That's not a nice perfect square like it was for 100. So you're going to have a certain answer. And what I want to tell you guys is that that's perfectly okay, because generally speaking, you're supposed to only use the quadratic formula when you're dealing with more challenging questions. And in those instances, you're most likely going to see irrational numbers like surds, okay? So that's going to be your final answer of here when you've actually simplified it. What I want you to do now is I want you to have a go of answering these questions. So give yourself 5 minutes or so for both questions, and then compare your answers with my answers. So for the first question over here, this is a kind of a trick question, but technically what you should have done first is you should have rearranged 39 to the other side. So therefore, this is going to be your equation over here. And once you've done that, then find out the values of A, B, C and plug it into the formula. So again, I'm showing you that there's a positive and there's a negative version as well. So if you do this, simplify this using your calculator, and you're going to get a nice perfect square in this case over here. So you're going to get 42 when you square root that. Hence, x is going to equal to 13, or x is going to equal to -1. For the second one, do the same thing where you find the values of A, B, C, plug it into the equation. In this case over here, notice that 9 plus 8 doesn't give you a nice number. It's going to give you 17. There's no numbers that could be square root exactly. So therefore, you're going to have to write your answer as a surd in this case over here. Now, before I quickly move on to the next part of today's lesson, I just want to quickly show you guys that again, that the only differences between your x-intercept values should only be these symbols over here, okay? All the numbers when you use the quadratic formula should be identical besides these two symbols over here. So now the second part of today's lesson is how do you actually find out how many x-intercepts are there going to be for that particular equation? And to do so, it's going to be doing finding the discriminant, and the discriminant is actually part of the actual quadratic formula itself, okay? So as you can see here, I've said the discriminant is equal to b squared minus 4ac. So that's this portion over here of the quadratic formula, okay? And it can discriminate, meaning it can find out the number of solutions for any quadratic equation depending on what value you get. So once you've kind of substituted the values into this particular equation over here, or this portion from the quadratic formula, if it's greater than 0, then this implies that you will you will have 2 x-intercepts. On the other hand, if your value is going to equal to 0, this implies that you will only have 1 x-intercepts. And lastly, if you've got a value that's less than 0, then this equals to no x-intercepts at all. So that means no x-intercepts exist for that particular quadratic equation. So let's go through 3 examples so you have a better understanding of what I mean by finding the discriminant. So in this case over here, all we're going to be doing is using the discriminant formula. So find out the values of A, B, C and substitute it into this formula over here. Now, if you substitute it in, notice that you're going to get a value that's greater than 0, so you get an answer of 27. And since that number is bigger than 0, this implies that you will have 2 x-intercepts, okay? Now, you haven't actually solved for x-intercepts, so there's no way for you to prove it, but I'm going to show you right now that there is, in fact, 2 x-intercepts. So I want to use the quadratic formula. Now, you're probably wondering, how did I get this answer? Remember, the quadratic formula was -b plus minus square root b squared minus 4ac over 2a. Since I've already found out what b squared minus 4ac is, which is 27, I've just substituted that directly into the formula over here. So that's what my working out is. So in this case, let's just simplify. So what's 2 times 1? That's just 2 in this case over here. And therefore, if I was to further simplify this, okay, you can simplify that as a third, because you can write that as 9 times 3, and you know that 9 is a perfect square, so therefore your answer is going to be like this. So shown over here, you've got the positive answer or the negative version as well, okay? And that just goes to show that you've got 2 x-intercepts, which was earlier proven by finding out your discriminant. So for the second example, again, I'm going to find discriminant. So how many x-intercepts are there going to be? Find the values of A, B, and C. Substitute it into the formula. Notice that for this particular example over here, you've got a number that's less than 0. So that implies that you have no x-intercepts at all, okay? And the reason why that is because if you substitute that back into the quadratic formula, Notice that you can't actually square root any negative numbers at all, and because we can't do that mathematically, this indicates that you can't have an x-intercept. X-intercepts doesn't actually exist for that given quadratic equation. And for the last example over here, find the values of a, b, c, put that into the discriminant formula. Notice that this is going to give you an answer of 0, and when you have an answer of 0 for your discriminant, this means that you've got one x-intercept, okay? And again, if you wanted to prove it by using the quadratic formula, go ahead. Notice in this case, if the square root of 0 is going to equal to 0, and since 0 doesn't really change the actual equation at all, negative 6 plus 0 is the same thing as negative 6 minus 0. It doesn't change anything at all. So your answer is still going to be negative 3. And notice that only gives you one x-intercept value. What I want you to do right now is I want you to have a go at using the discriminant formula to see whether you can identify how many x-intercept is present for this particular equation over here. Give yourself 1 minute and we'll go through the answers together. So for this question over here, find the values of a, b, and c and substitute it into the formula here. So if you guys have done this correctly, then you should get a negative answer. And because you've got a negative answer, then therefore this implies that you have no x-intercept. Now, I strongly recommend you guys to answer questions 1, 2, 3, as well as 4. These questions over here are the compulsory questions. And if you can, then these questions over here are optional. So questions 5, 7, 8, and 9. I recommend try to do at least one of the word problems over here, just so that you are more familiar with it, okay? So this is pretty much the end of today's video. Hopefully you're able to meet the success criteria. I'll see you guys again in the next video. Bye.